So out of the entire system of the collision system, the first thing I'm going to show is the collidable. As you can see, the collidable is the same way. We have a test pair collision and a collision. So yeah, it's pretty much the same. These are just basically a way so the user can easily get to the register collision or deregister collision and not have to call the collidable group itself. Just give the pointer and the class type. So the next thing I'm going to talk about is a collidable group and registering and deregistering to it. So basically what a collidable group is a collection of collidables of type C that we've registered for collision. So if I wanted a ship to be considered for collision, or a ship pointer I should say, then it would have to register itself to this collidable group and in the correct class type, which is why this collidable group, which is a singleton, is a templatized class with type name C. And when you register to this class type, you get the instance which calls the actual singleton's pointer, and then it inserts it into its collide group. So for instance, if this was a ship, it would call upon the ship's collidable base, and then insert the registrant, which is a set. Sorry, here it is. A collidable collection, which is a set of class C. And the way I went about showing that the registration and deregistration does work is that in the constructors for the game objects, three I have, which is battleship, ship, and then weird shape, I call register collision, which is inside of the collidable, and then it calls its collidable group of its class type, C type. So if it's a ship ship collidable group, and then it would register that ship pointer into the set of collidables to be considered. And to show this, in the level I have it creating one ship, one weird shape, and then two battleships, just to show that the multiple number does work. And in the collidable group, I have it on C out to the output, which shows you the number in that collidable group. So in this ship, it will register this type, which is ship type, into collidable group ship type, and then as you can see in the collidable group of ship type, it will register that ship into its collidable group. And just to show that it is a collidable group of ship type, you can see that the collidable group is of ship type. And this happens as well for the weird shape. As you can see, weird shape pointer, and then collidable group weird shape. So the collide col is of size 1 now. And then in the battleship, it also does the same thing. Registers battleship type. You're returning a collidable group of battleship type, and the size should be 1, which is true. And then now we do the same process, and the size should be 2. So it is registering in the correct collidable group. So the next thing I'm going to talk about and show that it works is the setting the collision pairs. So the function setting the collision pairs is in the actual collision manager, and all that does is basically gets the class C1 and class C2, which is put into the template parameters on the set collision pair, and it will call the instances, thereby creating them, and then inserts them into the collision groups to be considered for collisions. And I'll talk about this later, testing collisions. But for now, just to show that it does work, in the level 1, I have two collision pairs. There is the collision pair between the ship and the weird shape, and then the ship and the battleship. So just to show that it does work, I will go to the collision manager and then look at these. So the first one that should happen is the collision pair between the ship and the weird shape. So here we go. Setting the first collision between the ship and the weird shape. As you can see, the C1 parameter is the ship, and then the C2 is the weird shape. And then it'll add these. And that's pretty much working. Okay, so the next thing I'm going to be talking about is setting those function pointers in the collidable group. So when you call for a set collision pair, as talked about before, you also have the add test collision with other, which basically gets the current pair, the first pair in the set collision pair class template parameters. And so if it was ship and battleship, it will get the ship and call its function, which is add test collision with other, in which the parameter other is the battleship. So for this ship, it'll get the, for the collidable group base of ships, it'll insert into target tests, which is a set of targets. Not targets, sorry, function pointers. And then it'll insert the other it'll insert this ship's collision test with the other. That way it stores the collision tests with the other classes it has to do. So if you register ship and battleship, it'll have in the ship collidable groups, it'll have a function pointer to the battleship collision test. And just to show that it works, in the level 1, I have it so that you set the collision pair, and in the first one, it's the ship and the weird shape, and then the ship and the battleship. And then just to show that it works, so I have the battleship and weird shape, which will add the test collision with the other one, and then it'll insert that function pointer. And just to show that it works, I have it showing the size of target size. So after this insert, it should be 1. So it's 1. And then when I do it with the ship and battleship, it should show out 2 now. So it's adding that test collision instance, see how, and now it's 2. So that's working. Right, so now I'm going to talk about actually processing the collisions. And in the, what I basically have it set up is in the scene, and I've added a new collision manager, which is the collision manager. And in the scene, all it calls upon in the update scene is the collision updates. And basically, what that does, and for now I just put it in any place, but I will change it depending on my needs as the game engine goes on. For the process collisions, what it basically does is just calls upon every collidable group base, which is actually just to use polymorphism to actually call upon the collidable groups, call all test functions. And what this does is calls upon every single function pointer in that target list, as I talked about before, and that will basically call the collision tests. And so for for it being easier for me to explain, I'll talk about it as if it was a ship and a battleship. So the first collidable was the ship. So it'll call upon all the registered ships for collision, and then onto every battleship, registered battleship. So the other collidable group, it'll test if a collision happened between the ship and the battleship for every pairwise test. And if a collision did happen, it'll call the callbacks for the collision of the ship and the battleship. And just to test it, I have it all set up. So in level 1, I have one weird shape, one battleship. One ship, one weird shape, one battleship. And at the moment, I have a collision pair between the ship and the weird shape. And as before, the ship and the weird shape both register themselves on the constructor. So what should end up happening is when the ship's collision with the weird shape happens, it'll see out the ship collision with weird shape. And for the other callback function on the weird shape, it should say weird shape collision to ship. And just to test that works, here we have the weird shape collision to ship and the ship collision with weird shape. And just to test that it does work with multiples, I'll uncomment the scene manager, which has the set collision pair with the ship and the battleship. And so now you should see 4 different lines set up in the same way as the other ones. So weird shape collision with ship, ship collision with battleship, battleship collision with ship, and ship collision to weird shape collision to ship. So they're all there. And yeah, so it's working. And just to show that that the collidable will take over in the case that there is no ship. There's no ship collision event. It won't crash or anything. It'll just say battleship collision with collidable, because the ship is not registered for the battleship. So as you can see, battleship collision with collidable, which should have been the ship, but since I took it out, it's fine. And that's pretty much it. So last week I had a problem with my alarm manager that you pointed out and I didn't see, and that was basically when I wanted to overwrite the times corresponding to the actual alarm marker times. You told me that if I if I overrid the time, it would lose its place in the actual timeline. So I fixed that, and the way I did that was in the alarmable, I have it deregister first before registering for an alarm. And if the deregister doesn't find it, then it spews out a message saying we didn't find this, and then it registers anyway. And if it does find it, it'll remove it and then register. So that gets rid of that problem. And also in the alarm manager, you told me that not to use those for loops because they were kind of nasty use of those. So I changed those into proper while loops that just keep processing the top of the timeline until it finds the first future time. And that's pretty much it. Just to show that it works, I have alarm 0, which activates in 1 second, alarm 1, which is overwritten and will activate in 3 seconds. And the last one, which is alarm 2, has no callback, so nothing will happen. So you'll see 1 activated in 1 second, then 3 seconds, and then nothing. So that's the first one, and then the 3-second one, and nothing. And just to show that deregister works and doesn't break or anything, I have it constantly deregister alarm 1, and so it won't crash, and it'll just spew out a lot of errors saying alarm 1 has not been found, etc. So 111 has not been found, and that's it.